Okay, let's get started. Hello everybody. My name is Linwang Lu. I am software test engineer in Windows SE group. So today we're going to talk about scalability testing, performance testing, and reliability testing. So most of the time, you guys are already involved in the regression test. So regression tests involve like functional tests for specific, like you maybe have some documentation, all this specific for the component. So what we're going to talk about today for about half hour is we're going to talk about the whole system performance. Like what is the reliability of the whole system? Maybe not involved one machine, involved several machines. So here comes the idea, have some intelligent testing. It's not like, you go through some functional specification, okay, what function is supposed to test. It's something like you gain from the experience you test, or you gain the experience from the customer, the feedback from the customer. Hey, how your system behaviors looks like. So this kind of testing is more involved with some intelligent, how you design your test. And when we go through this presentation, you know how the WinSE is doing this kind of test, and you can extend your testing when you go back to India. So here is the agenda of today's talk. So basically, we're going to cover the bucket testing. So beside of the regression test, we're going to talk about all the buckets during our testing. And after I get the overview of the bucket testing, we are going to talk about scalability testing, performance testing, and reliability test. So what is the bucket testing? And people sometimes get confused, what kind of buckets when we talk in the Microsoft, in a real scenario, how the people use our system. So basically, we are talking about the security. So bucket testing involved security testing, performance test, interoperability test, accessibility, and install variations, and globalization and localization. So this afternoon, each individual owner will give you the detailed information about each specific bucket. Here I just give the overview. So for the security, most of time we are involved buffer overrun, denial of services, and the security issues. For the performance testing, we are talking about stress test, limitation test, and how your system perform in certain scenario. And interoperability testing, we test in different OS, different platform, and different hardware. And also we are going to talk about accessibility testing. Accessibility, like, for all the people, even they are disabled people, they still can use the system. And also we talk about install variations. Like, here you already know maybe like full cab installation, MSI installation, and check build install, and on a different OS. Then we're going to talk about globalization and localization. So there's some difference between the globalization and localization. So the owner will present what's the detail between of them. So there's a lot of things covered in today. So when we talk about what is the difference in general compared with bucket testing and regression test. So bucket testing is not happen every day on a daily basis. So it happens on per milestone. For example, when you go back, if you test on the beta version, or RC, or RTM, and it's not you test like every build it comes, you test how the performance looks like. And some tests you cannot even execute because some performance tests you need optimized build. So in a normal build, you cannot test performance tests because the build itself not optimized. So the data you get from performance testing will not going to match the baseline you get from our team. And also, keep in mind you have to get the baseline of the performance testing and some bucket testing. So once you go through this transition, ask the test owner where is the baseline located. Because if you don't have baseline, when you go back, you suspect some test performance issue, and you have to go back to the RTM version to get the base log. Then there will be a lot of time-consuming effort, right? So make sure in this transition you get all the baseline for the bucket testing. That's really important. Okay, that's overall of the bucket testing. So let's go to our today's my focus on agenda for the scalability testing, performance test, and reliability test. So what is the scalability testing? So people maybe know, okay, what is a performance test and what is the reliability testing? What is a scalability testing? It's kind of like ambiguous word. It's not really clear what is the scalability. So basically, scalability testing is specific case, is a special case for performance test. It's type of performance test. So what is the scalability testing? It's define the ability of the system to not only accommodate a growing number of clients' requests, but also provide a satisfactory level of responsiveness to each one of them. So it's not like based on the growing number of the clients or growing number of the machines, how the customer satisfied your system or your performance. It's not like single numbers. It's just like, if you put some more machine, what is the performance data you get will make customer happy. For example, I give you an example like network load balance, right? So in general, we tell customer, hey, normally you have four node clustering technology to serve your services. So maybe customer will have question, what performance I will get if I put 5 node in the clustering? What is the performance I will get? And normally the machine, when they talk to each other, they use some bandwidth. So you have some performance hit. So what is the ideal number to serve the customer? They can say, hey, this is the right number for me, and this is the right throughput for giving those numbers. So it's all talking about the satisfaction from the customer. Then for this testing, you have to get a general idea how customer use our system. So when you go through the bugs, you will say, okay, this is a performance bug, this is a scalability bug, scalability test bug. Okay, what is the customer scenario? So important things, you have to simulate the customer scenarios. In general, a scalability system don't have any limits. What that means? That means in your test environment, it's not easy to reach some limitation of numbers. For example, I have a network load balance set up. So is that easy to reach, like customer had like 2,000 connection per second? Is that easy? If your system easy to reach that number, that means your system is not very scalability. Why? Because if you add more system, that number is reached. That means you cannot grow those number as in your environment. So it's very likely customer will hit this problem. They will say, hey, your system is not scalability. I put more machine, the number cannot go up. So what happens if I want 3,000 connection per second? Can I add more machine? What should I do? So if a customer has this kind of question or scenario, that possible means we have some scalability problems in our component. Okay, in general, there will be little or no performance hit in a scalable system if the system is loading increased by provided with any amplifier resources. So for example, if your system is limited by the space of hardware, that means the hardware is like a hard disk. The hard disk is amplifier resource, right? This hard disk can increase. So which means our scalability testing should not focus on this amplifier resource. We should more focus on the functionalities. Another thing is scalability testing is not limits testing. It is part of the limits testing, but it is very have very good relationship with the limits test, but it's not the limits test. In the limits test, usually we test the numbers. So let's see, for example, how many DHCP server can handle the request for a certain period of time. And our scalability testing is testing our system cannot reach those numbers quickly. Cannot reach those numbers. So limitation testing is a guideline for your scalability. So you have those numbers. Is that easy to reach those numbers? If you can reach those numbers, that means your system is not scalability. During your scalability testing, you should identify what factor or scenario might have limitations. That's what we talk about limitation numbers. It's related with limitation numbers. So change your focus from small business environment to a large enterprise level. So in a small environment, you may have the numbers is different with a large enterprise. So you may need to focus on the large enterprise system. So test whether you can reach those limitations in a given amount of time. If you can reach those numbers, that means your system has some scalability issues. Here I have two examples for DHCP. So maximum numbers of servers you can authorize from the domain. And another one is maximum numbers of scope you can create on a server. So customers say, in most of my test scenario, I want this number like 8. So I want to have 800 scopes we can create for a server. But when we design the functionality, we say only have 500. That means our scalability is not good enough. Then we talk about what is a performance test. Performance test is most of the time involved stress. So it's focused on the critical performance areas. So some performance numbers can be reached by the stress, and some you have to go through specific test case, and ask each individual owner what is the performance test case for your component, and also get a baseline, and use most common user scenarios. Sometimes we get a question. Okay, sorry. Yeah, if you have any question, you can just interrupt me and ask the question. Use most common user scenarios. And sometimes, we try to do performance tests. For example, for the network load balance, right? We hit like 2,000 TCP connection to hit the server, or maybe 5,000. Is that really scenario we want to hit that numbers? So we should use common user scenarios. Performance metrics should be sustained over a period, which means performance data should be kept stable. Like for the Win2K, the number should not change. So we should not, for the RTM, network load balance, you can have 2,000 connection per second. And in the SP4 or SP5, you should also reach that numbers. If you cannot reach the numbers, that means you have some performance issue. So you may want to find out what is the problem with for this performance issue. And note that performance testing should be done only on an optimized build. So now most of the time, our optimized build is released on RC time frame, maybe after beta. So before the beta, normally you don't need to do any performance test. So for the performance testing, first you have to identify the critical performance metrics that you need to test in your company. And most of the time, the services has a performance data, like DHCP services, or WinSE services, or Win management services. So most of the services, they are more focused on the performance, because why? So many people want to use these services, not individual applications. And prioritize and establish the baseline for all those performance metrics. It's good WinSE already set up these metrics for you, so you just follow these metrics. Then define what level of priority testing is needed and on what kind of build. So most of the time, you cannot execute all the performance testing at one chunk. You have to say, okay, in the beta, we do 1/3 or 2/3 of our performance testing. Or in RC, we do another part of the performance testing. And usually, performance testing involves a lot of time, and a period of time and period of the machine involved. And I remember in the network load balance, we have 32 nodes, which means 32 machines join a big cluster. And not only that, within this 32 node and 32 node cluster, we have to generate enough of traffic. So usually, when we do this, we have like we ask all the SP stress team to contribute some machine. Normally, we have like 30, 40 machines to stress this 32 node. That's a lot of work need to do to set up this environment. So it's not like you have to do in daily basis, or there are some milestone. After some milestone, you can do this. Performance tests should be same as we wish to use to establish a baseline. So once you have the baseline, you have to keep what is the specific requirement for this baseline setup. For example, they use like P2, okay, machine P2 to get the performance data. So when you go back to testing, you have to use exactly same type of machine. So because the different machine have different performance, it will affect your performance data. And you don't know, okay, is this really performance issue, or this is like just machine related, or ampli resource, right? We're talking about amplify resource, which means the performance data is heavily related on the hardware resources, which is can amplify. So most focus on you should have, when you go to the transition, you have a system like process speed, number of processors, the network card speed, and model of the network card, and the number of NICs in the system. And also have physical memory size, disk size, and speed. And most important is SKUs, OS SKUs. And also you need to get workload, how many clients hitting the system. And the network protocol use. Are they using DHCP or they use UDP? Because different protocols may have the different connections requests, right? When we talk about like different performance, like when we talk about network and load balance, we say 2,000 connections. Are we talking about TCP connection, or are we talking about UDP connection? Because a different connection have a different performance hit for the system. And we also need to get the data for server and services configuration. Okay, so until now, do we have any question about scalability and performance testing?
You said that the testing scenario should be same as the one when baseline was drawn. So if there is an enhancement in the performance, say feature has been enhanced, so then the baseline would be void, right? Have to get the new one.
That's right. If we, the question is, what happens if our functional change to make the performance better in the latest service pack compared with the baseline we have. So, which means our performance is not down, but it's up. What are we going to do? So the answer is we should use the right performance data. We should use the right set of tests to get the new baseline for our performance data. If the performance going up, then later on we can use this performance, because we know this performance change may be requested by the customer. So we don't want to go into some scenario like in SP4 your performance is good, then SP6 your performance is bad. And this is a really bad scenario. If the customer, they find a bug and they say, okay, there's a performance issue, then we fix it, and in the next service pack we have this bug again. That means our testing didn't cover this scenario. We tested, we give the package, but in the really service pack, the problems go back again. So this is really bad regression. We treat this as a regression. So if the performance go up, you should get your own baseline. And moving forward, you can compare with this baseline. Okay, reliability. So reliability consists of tests that help measure the robustness of the component when we use the stress testing. So the measure in terms of availability, which is uptime divided uptime plus downtime. And usually we think we should have 24 hours a day, 7 days a week, 365 a day a year. And we hope we can have 5 nines. And we have specific benchmark. And when you go back, you don't need to have to this benchmark, because in-house we don't test this benchmark. There's a specific benchmark team, they get this data. But we have our own reliability data. You need to get those baselines. So reliability more focus on the resource leaks. Do we have any resource leak in certain period of time? And how long our system can stay available, like 20 days, a month, how long our system can stay available. And memory corruption. Each time when you have memory corruption, it's not like your system immediately shut down. And the memory corruption will continue growing until in certain point and your system is crashed. Like buffer overrun, right? Each time you have like 1 byte, 2 byte buffer overrun, that will cause any problem. But until your buffer overrun reach the return address of some function, it will jump to some other place. And other place, they don't have the right code to execute, and your system crash. If you just override some local variables, your system looks okay. But how you can find this problem? You're doing the stress. You're doing the reliability testing. Put a certain amount of time to make sure you can amplify the problem you have in your system. And also, we doing reliability testing to find the deadlock issues and the risk conditions. Reliabilities have some things to do for the testing. So basically, we should enable the driver verifier for the driver testing. For example, for the TCP.sys, TCP/IP.sys. This is the driver. So when we do the reliability testing, we want enable driver verifier. And we also want put page heap. We also want enable G-flags and page heap, UMDH, sysattack, or some user model services like application verifier to track all these problems. So scalability testing, we have several example bugs like 7635. Remove the limitation of the DHCP authorization servers in the Active Directory. So that's a design change. So most of the time, your scalability testing is involved a functional change. It's involved a functional change which you defined before. And performance test is Like 15454 is a DHCP server snapping take 12 minutes to display 10K reservations. So this kind of bug is like, okay, it's not really like a functional bug, it's like performance. So maybe they can display 10K in 10 minutes, or maybe they can like 20 minutes. But the customer say, this is not good, I want to have 12 minutes. So reliability is involved all the stress bugs. So until now, do we have any questions? Okay, more info, you can go to WinSE test. There's a lot of information about bucket testing and scalability testing and security testing, those bucket tests. I'm sorry, kind of. Okay. Scalability. Okay. So remove the limitation of about 280. Okay. The question is, what is the bug example for the scalability? So here is a bug 7635. Remove the limitation of 850 DHCP authorization server in the Active Directory. So in the Active Directory, usually we can set up below than 850 DHCP server. But in the real world, in a big enterprise, they want to have more DHCP server in the Active Directory, but they have the problems. We cannot authorize so many DHCP servers. For example, in the real world, right, not all the company, they have so many DHCP servers. Only like, I don't know, American Express, the big customers. They have a global environment. They may need so many DHCP servers. So in the test scenario, normally you cannot find this problem. So during these three buckets, the most difficult bucket is scalability. There's no easy way you can justify, okay, what is the scalability bug? What is the right number for the customer? Because you don't have the business justification, know what is the right values for them. The performance testing and reliability testing is kind of a little bit less intelligent than in the scalability testing. Okay.
The website you have published, does it contain the baseline for all the components, the baseline values, or is there any single location where we find those?
No, actually, yeah. The question is the website in the WinSE test. Do we have any baseline for the bucket for the scalability, performance, or reliability, or all the other buckets? Actually, the answer is no. We don't have. So probably that's a good idea. I should bring this to. We should have like central place to keep all this performance data in the central place, all these bucket data. Because right now, you have to ask each individual owner to get all this baseline. There's no, as I know, there's no central place to hold all these data. I try to get this information and send to you guys.
What are these race conditions under reliability?
Okay, risk condition is if you have a single resource and you have multiple threads to try to get this resource, and you have the performance issue. So if you give this resource to somebody else and this thread maybe wait a long time. So how you can handle this, like in this risk condition scenario, how you can better serve to the different thread or different application to use the limited resource. Okay, we almost ran out of time, so I'll just go through.